Okay. Okay. She says she wasn't yelling, she was projecting, but we are now recording, so thank you, dear. Okay. Okay. All right, let me show you what the objective is going to be today. I'm going to share my screen. Let's see, share screen one. Okay, screen is shared. And there's a bunch of code here. This exact code as it is right now, I may change it a little bit during class, but this exact code is shared, is in the M drive under handouts and labs, lab 7. There's a whole bunch of stuff there. So it's on the M drive, handouts and labs, lab 7. There is a ton of stuff in that folder, among them this code. The objective of this program is in our main program, ultimately we say printf hello, and it sends it over the UART to the PC or whatever device is connected to the 328. And this is there's a bunch of other stuff here, which some of it I may get to cover today, some of it I won't, it will spill over to Monday. But even though doing this printf this way is not the most efficient memory-wise, it certainly works, and I don't think you're going to run out of memory. One of the questions that, and some of these, this printf capital P will address, and we'll talk about that on Monday. When I say printf hello, strings are frequently kept in RAM. So if I have a string and something in quotes, it's kept in RAM. But when I turn off the power, RAM goes away. So how does it get back? And the answer is it also stores it in the program memory. On power up, there's a little routine that runs as part of the initialization. Well, not on power up, on power up, when there's a C program loaded, there's part of an initialization routine that copies those strings in program memory into RAM. Which then begs the question, isn't that taking up space twice, and isn't there a penalty? And the answer is absolutely yes, there is. The fix to that is if it's not going to change, like this string in quotes here, we know is never going to change. Why can't I just keep it in program memory? And the answer is you can, and there are ways to do that. There are some effectively macros in C, pstring, printfp, that look for information to be in program memory only. And that's going to kind of be a Monday thing. This is easy to understand. It will work just fine for the purposes of your lab, but just recognize there is a double penalty in terms of space. So printf, when you were in 160, always just printed to the screen. We need to write some special routines that says, okay, printf is now going to print to the UART. By modifying those special routines a little bit, we could make printf so it could print to, say, an LCD display, or possibly a seven-segment LED display, or some new device. Today, we're going to focus on making it print to the UART. All right, so let us.
This is for today's lab, correct?
This is for today's lab. That is correct.
Did you ever manage to put the printout in the M drive or no?
Yes, that I believe everything is on the M drive. Again, under handouts and labs, lab 7, there is a ton of stuff I put there. And just because the video on Zoom will be super choppy, if I'm VPN'd into the university, I can't show you that, but I looked before class and I think everything is there that needs to be there. The only thing I actually haven't done is an official lab write-up. But as I said last time, it's type a string in from the keyboard, which is an expression, and use the parse routine that I gave you last time, which is definitely on the M drive, and spit the result back to the PuTTY window. So you'll be typing on the keyboard, and it will come back to a PuTTY window. Also on the M drive, I told you there were two different ways of doing a queue. The one that Dr. Weil wrote, or Ben wrote, is probably much better and will be used in a production environment. The one that I wrote that is there as well is probably easy to understand. I know those of you who have not had 161 have never seen this dash arrow before. It's the same as star m dot buffer overflow, which you also haven't seen. And you don't need to understand how it works. You're welcome to look through this. I suggest you do. But there will be many times in your career when you use software that both you haven't written and you don't understand how it works, and you don't need to understand how it works. Have you guys written software to control any of the scope or the voltmeter or signal generator in lab? Do you write any code to do that?
I don't think I
I
have.
don't believe so.
Okay, so you haven't written any, all right. How do I see all of you? When I share my screen, I'm seeing most of you. That's better, okay. That's it. All right, that's a little better.
I walk away for 2 seconds. Now there's pointers on screen.
There's pointers on the screen? Oh yeah, okay. Yes, there are pointers. And I was just saying that if you're in electrical, you've never seen this before, and you don't need to understand it to run it.
Oh, all right. Just caught the tail end.
Maybe it's in junior year, you'll write code to actually control the signal generators in lab. You'll be using routines, and you don't know how they work. You may or may not be able to see the actual routines. And in general, you don't care how they work. All you need to know is I can call a function like isEmpty, and it's going to do something and give me useful information. Or I'm going to call a routine like DQ or NQ to put something in the queue or take something out of the queue. How it actually works, how that queue is implemented, I don't really care. As I said last time, a queue is basically a circular array or a circular buffer. There is a routine that puts things into that buffer called NQ. There is something that takes things out called DQ. In our case, those things are characters. You have basically a head and a tail pointer that are chasing one another. And as long as there's some empty space in that queue, you can keep putting stuff in it. And you've got a head pointer that runs around in a circle and a tail pointer that chases it. Head controls where stuff comes out from. Tail controls where stuff goes into. And I'll show you, in fact, an example of some buffer overflow and when we have a problem in this code. But this is the buffer C, buffer H is what I implemented in this program. It's actually what I'd suggest you use because it's a little bit easier to use than the code that, the other code I wrote. To add mbuffer into your project such that it will see it, whatever you name your project is, I know we haven't talked about this before, but a solution is what you create in both Atmel and in Visual Studio. A solution can contain multiple projects. You'll see solution items, and then the first one is USART printf. That's what I named the project. If I right click on the name of the project here, I can, somewhere, I think there's, yeah, okay, add. You can add, and you can either add a new item or an existing item, I would suggest you put both mbuffer.c and mbuffer.h in the same folder as your main.c file. And then you can just say add existing item and add those two things to the project. Or you could start with this project and add your own stuff, and then they're already there. Up to you. But so if you want to add header files and auxiliary C files, you need to right click on the project name, add existing item. If you put them in the right folder, or actually wherever they are, you can just add it. Right, that's the mbuffer.c, mbuffer.h just has standard definitions as a structure. I know those of you in 160 have not seen structure. I'm sorry, those of you that are electricals have not seen structures. It's similar to a class in C. It's almost on the same idea as a class. Here are the prototypes for all of the routines that are exposed within the mbuffer code.
I think we talked about
Again.
structures a little bit in 160.
Okay, is that a question? No, okay, that's not a question. Okay. All right, so let's look at the main program. All right, there are a couple of new includes that you haven't seen before. IO, you've seen interrupt. Program space is going to be for avoiding that double space problem where you store something in program memory as well as RAM, even if it's never going to change. That's probably we could do without that today, but on Monday we'll look at that. FCPU, delay, standard IO.h. Hey, we haven't used that yet. Standard IO.h gives you access to the print routine, and print is going to be dependent on a put character routine that we're going to write. mbuffer.h, I put that in quotes instead of angle brackets because that's not a system H file, it's not a system header file, it's local to this program header file, and the C syntax says you put it in quotes. I've got a couple of, I got a routine up here, which I probably should have prototyped and put it after the main program, but I didn't. UART 9600, that's going to initialize the UART. I set the baud rate register. I've decided I'm going to do 9600, 8 data bits, no parity, 1 stop bit. I initialize the baud rate register. 103 is the constant for 9600 baud. I've done all the flags. The A register, the defaults are going to be A-OK, so I didn't really do anything with that. I split the B register up into 2 different pieces. These are kind of constants. For the purposes of the code I'm showing you, I am only enabling the transmitter. You're going to have to look at what's called the libc documentation. The PDF file is also on the M drive and under Lab 7. And see about doing either a scanf of some kind or a get string of some kind to get the data in. All right, I'll tell you this today, just I'm going to make this a 2-week lab. So because I'm going to make this a 2-week lab, I'm going to really force you to know as much as I can about the UART and using it, because there's going to be some stuff that you don't know, you don't have the hardware to cover it. So the things I can do, I'm going to do really in detail. And there'll be some things in this course because of our situation, SPI, that I guess you don't have the hardware to cover it. So I'll talk about it, but you won't be able to actually do any labs with it. Okay, so I just separated, so you need to figure out how to receive characters. You're going to have to write either a scanf or a get string type of a function in order to get characters in. And there is a libc manual in Lab 7 PDF file, and you can look through that for some details. And in fact, a lot of the code that's here came out of that manual for printf. The size of the buffer needs to be larger than the greatest amount of characters you're ever going to put into it. I make a relatively small 64. It could be up to 256. I'm making it 64 just so I could demonstrate buffer overflow for you. I would suggest, of efficiency, whatever your buffer size is, you make it a power of 2. And the reason for that is it will certainly work for any value. But when you begin to do mods that are not a power of 2, the code becomes a lot more time consuming. Dividing by a power of 2 or modding by a power of 2, it's either ANDing or shifting. When you go to non-powers of 2, there's all kinds of hideous divide routines that need to get done. So suggested it's a power of 2, but it doesn't have to be. I have my transmit buffer, that is characters from the 328 PB to a receiver. You're probably going to have a receive buffer as well. Okay, M buffer is a new data type, and that is defined in, go back to this header file. M buffer is kind of like the file or file handle in C. M buffer is going to point to a block of data that contains the size of it, the buffer, the tail pointer, the head pointer, and an overflow flag. So for now, it's just a new magic data type, and you're going to have pointers to that data type. I've got a buffer pointer or a buffer for my transmit, buffer for my receive, and I've prototyped the put character routine, which has to be written with 2 specific parameters. It has to take the character to put, and it has to have a pointer to a file stream. Again, file, you may not have liked it when you were taking C, but it is a data type and it's here to stay. You need to get used to it. So I'm calling it stream for this file stream, character C.
Why is it a pointer?
Why is file a pointer? Because you're passing an address to it, and I guess your question may be more of why isn't mbuffer a pointer?
I mean, you're using a
The real
pointer
question-
in mbuffer, but I was asking about, like, why
Okay,
does the file have to be a pointer?
Yeah, file has to be a pointer because that's the way it's implemented. When Ben wrote the code, it makes more sense to me to make mbuffer or TXQ would be a pointer to mbuffer. I understand why he did it the way he did it. It could have been done either way. It's just more dereferencing in the mbuffer routines. So file is a predefined data type, which you need a pointer to. Again, this was probably a decision made about 1970 by a couple of guys who like to drink, and that's the way they implement. That's the way they implemented it.
It's a little ugly,
I
but
would tell you
whatever.
that's the way it's been for the last 45, 50 years, something like that. Right. For those of you who are computer engineers, you have heard the term standard out and standard in. If you're an electrical, you probably haven't heard those terms. Standard out by default is the screen. Standard in by default is the keyboard. It is possible to change those defaults. And in fact, we are going to change it in the main program right down here. Standard out, which is one of those reserved variable names, I'm going to set equal to my standard out, or the address of my standard out, which I defined up here. I need to tell it for standard out, I need to give it a routine to output a single character. It's kind of like if I tell you how to do X, if I tell you how to eat with a spoon, you can eat bowl after bowl of oatmeal as long as I tell you how to eat with a spoon. Printf is going to look at how this stream is set up in order to output characters. Printf is going to figure out what characters it needs to output and then repeatedly call the function specified here, this put character, and it's going to use that again and again as it needs to. I forget what the second argument is. We're going to make that null, and this flag says this particular stream is going to be for writing only. Right. Next step, I've got a couple of character strings. One is longer than 64 characters because I want to show you what happens with an overflow. Space, the final frontier, these are the voyages of the Starship Enterprise. And the other one, the result is, and a number, just to show you how I can do output with values. Let me pop a cough drop here. All right. Let's focus on my main program. Got a bunch of stuff in here that I'm also gonna, probably not gonna get to till Monday. But my main program, I set temporary variable to 0. Buff init is part of mbuffer. Prior to using the queue, you need to, the queue buffer, you need to initialize it. I specify the address of my queue handle, which up here I said was of type mbuffer. I specify the array where I'm storing the characters, which I go up another line, which is an unsigned 8-bit array. I specify that, and the size of it is buff size, which a couple of lines above that, I said was 64.
What's in the header file, by the way? Is it just the structure prototype?
In the header file is just the structure prototype plus prototypes for all of the functions.
Okay.
And again, you can look at the C file and you can look at what all the code does. Whoops. Right, so if I wanted to make this buffer smaller or bigger, if I was limited on memory and I knew the program didn't need more than 32 bytes in the queue, I could change that to a 32. I could change it to 128 or 256. Right. So this buff init and this standard out equals address of the thing I defined up here. Pretty much sets up the queue such that I can use printf. I call my routine to initialize the UART to 9600, 8 data bits, no stop.
Does it need to be its own function? Is there something special about that, or is it just convenient?
No, I could put the code in here. But if I was doing this in a production environment, I'd probably write a routine UART setup, which takes the baud rate and how many stop bits, how many data bits, and just adjust everything accordingly.
Yeah, I was going to ask why you didn't, but I mean, it's just fine for the one.
Seemed like the thing to do, I don't know. Next piece is enable interrupts. I delayed just a little bit. And even though I don't use T, I'm now going to say print hello, delay for 10 milliseconds. And I think that's all I have in that loop. I got a bunch of other stuff to show you eventually, but print hello.
Why do you delay after the SEI?
Because I want to show you that as soon as I do the SEI, an interrupt gets generated. When I show you how this runs, I'm going to set a breakpoint and show you that an interrupt gets generated even before I come to this printf. So that's why I do that. Good question. I probably don't need that there. Right. Let's look at the put character routine. And there's a lot of routines that are dependent on each other. In the put char routine, you might think all I need to do is NQ whatever the character is, and I'd be done. There's a little bit more to it than that. First off, you'll note this file stream over here isn't actually used. Because I only have one output stream, I just kind of ignore that. It needs to be there to work with the rest of the system, but I'm ignoring it for now. NQ is a critical piece of code. Way back when we first did interrupts, I talked about critical sections, how if you got interrupted from inside of a piece of critical code, all hell could break loose and things would break. If I look at this NQ routine, which is here, suppose I got interrupted. I was inside of this routine and I got interrupted between these two lines. Tail gets checked. Tail could possibly change during an interrupt. So if tail gets changed here, then it gets changed again here. The queue is going to be at a really uncertain state. Most likely all hell is going to break loose and the program's not going to work. So whenever you NQ something or DQ something, you need to treat that as a critical section of code, turn off interrupts, and then turn interrupts back on again.
If it's always critical, can't you put the CLI and CEI in the NQ routine?
In this case, yes. You might want to use that queue routines for something else where it wasn't a critical code section. And again, one of the adages of writing functions is a function should do one thing. So it certainly wouldn't save you anything time-wise. So it would be a design decision. I think the thought was with that queue routine is that's designed to control queues. When you're just doing a general queue, critical code isn't a thing. Here, where you're doing the put char, it is a thing. So that's kind of my thought on why you do it here. I then say, okay, this data register interrupt enable, I'm going to enable interrupts when I put something in the queue. Now, wouldn't they already be enabled? Well, possibly, possibly not. It's possible if I had output everything a while ago and there was nothing else to output, I would have disabled the interrupt because you don't want it to keep generating interrupts if there's nothing to put in the data register. So down here in this routine, we're going to see we actually turn off interrupts. But anytime I put a character into the queue, I'm going to enable interrupts. Now, if interrupts are enabled, I periodically am going to come into this anytime I finish shifting out a character from the transmit buffer. The character in the data register will get loaded into the transmit buffer, and a data register empty interrupt will get generated. First thing I do is I check, is the queue empty? So TXQ is the handle. Is the queue empty? If it is, I'm going to turn off the data register empty interrupts. I write a 0 into that bit. If it's not empty, I come down here, I DQ the next character into T. I write that to the data register. I could do that in one statement, but T can sometimes be useful for demonstrations or debugging. That's why I left it that way. Okay, now that's pretty much all of the code. Let's try running this. And I am going to set a breakpoint. I'm going to set a breakpoint at this T++. And I'm also going to set a breakpoint here. Right, so I'm going to set a breakpoint inside of this interrupt service routine. And I'm going to set a breakpoint initially here. Question to think about, which breakpoint is going to fire first? Is it going to be here, or is it going to be in the interrupt service routine? No, let's find out here. Okay, I'm going to do control, no, not control F5. I'm going to do start debugging and break. There we go. Okay. So that's the first line of executable code there. I'm going to do F10, and then I'm going to just do F5 to run to a breakpoint. No, the first breakpoint, before I even get to my printf, I go into this interrupt service routine. Well, why is that? Well, I don't have the data sheet loaded, but if you went into that PDF file and looked at the UART, on reset, the DRE flag is set to 1, saying the DRE register is empty. The transmit register is obviously empty because I haven't given anything to transmit. So I can immediately put something into that UDE register, which could then be shifted into the transmit register. I'm sorry, could then be loaded into the transmit register. Bad use of the word shift there. So since there is nothing in the UDE register, an interrupt gets generated saying I could put a character in there. The queue, and I'm not going to step through this code, but the queue is empty since I haven't enqueued anything yet. So if I hit F10 once, it's going to go to this line. Okay. And I am going to turn off interrupts on UDRE empty or DRE empty. So I won't get interrupted again until I put a character into the UDE register. So now I'm going to hit F5 just to run. And I come to this print statement. All right. Let me hit F5 again. All in the background, all magically now, as a result of this printf, the compiler has written code that's going to call putchar 5 times here to print out the word hello. Now, something I should probably do, actually, I have putty running, but let me close putty and just start it up again. Yeah, close the session. I'm going to run putty. Again, I know I've gone over this before, I'll go over it again. To set up putty, you need to click on serial. For the COM port number, you need to run device manager. I've got device manager running, but I thought I had device manager running. That device manager? Oh, okay, that's device. All right, let me just show you how to run device manager again, just in case you don't know. go into the search box, type device manager. Click on it. It may tell you you're a standard user. If you're in the labs or on VPN, on the remote desktop, it will tell you that. But yeah, it's okay. I don't want to change anything. I just want to look. Go to ports, common LPT, expand that. You'll see the ME debug virtual COM port, COM8. So COM8 is what you want to put into here. So change that, it will default to COM1. It could be anything between COM1 and COM95 or 98. I do not understand how it enumerates COM ports. But
Wait, so how are we checking that again?
okay, how do you check? You go into, you need to run device manager. So you go into the search box, type device manager, and under ports, expand that. You will see one ME debug, which should kind of look familiar, virtual COM port. It will
Okay, I see.
be COM8. In my case, it's COM8. Your mileage may vary. It will probably not be COM8. And I don't understand how it enumerates and assigns COM ports. But
That'll only show if we have the thing plugged in, right?
that is correct. Yes, you have to have your board plugged in order to see what that is.
Okay.
All right, so I've made this COM8, 9600 baud. If it's something other than the default of no parity, 8 data, 1 stop, you need to click on serial, and you can set it to 9681, no parity. Okay. If you go back to this, you can, what I did is I typed a name into the saved sessions. You can give it a name like 328PB 9600 N81 and save that setting. So the next time you go into PuTTY, you can just click on this and say open, rather than doing everything each time. And you can have a whole bunch of different settings saved. Right now, there is my window, which at the moment isn't doing much of anything because I'm at a breakpoint. I'm going to hit F5 here, and let's see what happens. Right, I come down to the interrupt service routine. Now, what has happened so far? Well, printf in the background called putCar. Now, why did printf call putCar? Printf, there's a printf. Printf by default is going to print to standard out. Within Visual Studio, standard out has a default of the screen. Within our environment, it doesn't have any default. I specifically here had to tell it address of my standard out. Where did that come from? My standard out I defined by means of this special magical routine written into the not the operating system, but written into the runtime of our C compiler. I specified my special routine to output a single character. My special routine here, I actually have to write that routine. Hence, it went to that put character routine, turned off interrupts, put a character into the queue, enabled interrupts, and then made sure or turned on the interrupt enable for UDE empty and returned. Now, as soon as, can I do a tray call stack? Is that useful? No, it's okay. That's not useful. All right. As soon as I enable the interrupts here, the interrupt for data register empty would fire because there was nothing in the UDE register and there's nothing in the transmit register either. I am going to come down here to the interrupt service routine. Is empty is now going to be false because there is something in the queue. So I'm going to hit F10 and I would expect to go to the else part here. F10, lo and behold, look, we're at the else part. I'm going to dequeue a character and put it into T. F10 once again. Okay, T was optimized away, unfortunately, and I didn't set this to do no optimization. But T would have been the letter H. I put that into the UDR register. And if I look at my PuTTY window now, I would expect to see an H there. And I don't know if you can see that or not. Can I make that any bigger? Change settings, window appearance, font. That may require a restart. I don't know. Let's see. Nope, no, okay. I can see an H there. So as soon as I put that into the UDR register, it moved it to the transmit register, loaded it to the transmit register because there wasn't a character previously there. It began to shift it out, and I now see the H in the PuTTY window. All right, what I'm going to do now is take the breakpoints out of this and just hit F5 to let it run. And let's look at the PuTTY window. And it's just going to keep printing hello, 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 forever and ever. There's no such thing as control C'ing or control breaking to stop this because I haven't done anything, well, because the 328 isn't receiving any characters. And if I type control break or control C to PuTTY, it doesn't have a place to transmit it. Actually, I take that back. It sends it over the transmit line to the 328PB, but I'm never even looking at it on the 328PB. So hello is just going to keep printing and printing and printing. And if I make that smaller, okay, you can see that. All right, so.
How would you be able to implement something like that where you can like make an escape key so you can make it stop?
Okay, the question is, how do you implement something so you can control C it, or how do you implement receiving anything? That's the big piece of this lab that you're going to have to figure out. You're going to have a receive buffer. I commented it out, but you should uncomment that. There's going to be a receive queue. And you're going to have to write some kind of a special get character routine to receive characters. You need to look at the libc documentation, and it's in the Lab 7 folder, a PDF of that. You will find, again, you will find a lot of what I did today is right out of that manual, including something close to this. You need to write some kind of a UART get character routine. You need to set up a my standard in, and you need to do standard in equals ampersand my standard in. Once you have done that, you can magically use scanf or get string, something like that. Your choice.
So for the lab, we're just basically taking what you have here, right? And then we're implementing scanf with 328PB, right?
That is 2/3 of it. So being able to output stuff with a printf is certainly a piece of it. Being able to input stuff with either a scanf or a get string is a piece of it. And the third piece of it is using that code I wrote for the parser, and it's on the M drive in Lab 7, implementing that so that you can get string or scanf in an expression and then printf the answer.
Okay, so we're scanning it in, right? Then we're passing that to the parser,
Correct?
and we're printing it out, right?
Correct.
Okay.
Exactly.
So the parser will work as is because it uses scanf and printf once you set those up.
Almost correct. The parser uses getS, either get string or getS, and printf, because you're reading an entire string instead of individual values.
Right, so that'll require modification, but
Again, I point you to that libc manual, and I am trying to force you, rather than giving you a bunch of stuff and just having you puzzle it together, I'm trying to force you to read documentation, because I'm very mindful in 388, you're going to have to read documentation. So trying to get you to look at the documentation and figure that out ahead of time will be useful for 388.
that just sounds like Stack Overflow with extra steps.
Well, welcome to a career as a programmer. Yeah, what you say, AJ, is very true. A lot of programming is somebody's done something close to this before. I mean, look, just looking at that eval expression routine. I went out to Stack Overflow, found something that was close. I adopted it to work with Visual Studio, and I think a little bit clearer. It was a little more cryptic on Stack Overflow. I gave credit, and yeah, there's a lot of stealing stuff from Stack Overflow.
The essential copying and pasting from Stack Overflow, 2nd edition.
Well, it's good to know that I can do that.
Oh yeah, just credit it.
Of course,
If you
naturally.
don't read programmer humor on Reddit, you should. There was once something there that I guess a guy's girlfriend was taking a programming course. He's a professional programmer, and she said, or he asked her how she was doing with her homework, and she said, "I guess I'm doing okay. I ran into a bit of problems, and I Googled Stack Overflow and found what I needed. I don't know how you professional guys do it." And he's thinking to himself, should I tell her?
Well, about that.
Yeah. All right, the other piece I just, okay, the one thing I wanted to show you here, let's make this instead of hello, actually no, let's leave that. And let's just add, okay, let's leave that and comment it out. Just to show you how to break this. What did I call a string? Too long? Okay, let's not use that yet. Let's actually just make that blah. Okay, so now I've got a string that is more than 64 characters long. And
I think it might be missing a semicolon.
I probably am. Okay, yep, we'll change that in a second. All right, let's delay 100 milliseconds there. And you are right, I'm missing a semicolon. All right, what I'm going to do is set a breakpoint here. No, right there. Oh, okay. While this program is being debugged, I was editing it. So now let me stop it. Let's say start debugging and break. Right, I'm going to set a breakpoint here. So let's, okay, F5 to that breakpoint. Let's look at my putty screen. Is there a way I can clear that? Clear scroll back? No. Clear everything.
Reset terminal usually does it.
Reset terminal, thank you. Okay, reset terminal. All right. I'm going to F10 to execute that printf. All right, and let's look at this. That looked kind of weird, huh?
Back. What happened to the rest of it?
What happened to the rest of it? That's a really good question.
Let's find out.
Characters is this thing. This is column 17, and that's column 92. Alexa, what's 92 minus 17? 75. Okay, so 75 characters, or 75, minus 64 is 9. So it's reasonable to assume that maybe I got a couple of characters out before the buffer wrapped all the way around, and I got an overflow condition. And that is, in fact, I believe exactly what happened. So the head pointer is where I'm grabbing characters from. In the time it took me to output 4 characters, I was able to put out the remaining 71 characters or whatever it was, which wrapped all the way around 64 and began to overwrite stuff. Eventually it overwrote, and the queue thought it was empty when the head and the tail pointer were equal, and it just stopped outputting anything. Right, that's the buffer overflow situation. Bottom line is, you want to make sure your buffer is big enough such that that isn't going to happen. There is some, let's see, okay. There are, within breakpoints, and we'll talk about this next time, within breakpoints, there are actions that you can do. So you can right-click on a breakpoint, it changes to a diamond, and in the output window, which I'm not displaying, but you can go to I don't know, view and set up output window. You can have it output intermediate values. So it's potentially not going to break on a breakpoint like this, but it will continue execution. You can uncheck this and have it break, or you can just continue execution and output a debugging message to the output window. A lot of powerful stuff in here. Okay, for now, let's close that. You have a routine to output stuff to PuTTY from the 328 PB. You've got sample code to initialize the buffer, and you're going to initialize the receive buffer too. The magic that you need to come up with is a my standard in, and setup stream is the same function, but slightly different flag over here. And writing a get character kind of a routine. Those are the pieces that you need to do. If you can get your get character routine working in lab either today or Monday, you are doing really good. If you don't want to focus on that right away, and you might not want to look, I'm probably going to give you a little bit more on what's happening on Monday. A thing to do in lab today would be get the expression eval routine to work within BatML Studio. And instead of doing a get string, just give the or set expression to be a constant and see if that will output the correct answer. So that's another thing you can do in Lab today. Okay. When I did this, I disconnected the proto board from the 328. I don't know, thinking about this. No, it's okay. You should be able to leave it plugged in. Actually, let's just try that and see. I'm just wondering, is any of the hardware on this board going to interfere with the all right, if I take this breakpoint away and say F5 and come over here, all right, even with this, and if we stop this, how do I stop it? All right. You'll see it sometimes seems to work pretty well, and then it wraps around and loses the last, I bet it, last few characters. So there's obviously a problem with this. And where it actually loses its cookies changes to some degree. Well, I guess it doesn't. All right, but there is obviously a problem because I'm overflowing the buffer. One of the things I could do is within mbuffer, maybe that doesn't get brought out. Here. Oh yeah, okay. Note that if the buffer is full here, I set this buffer overflow flag to 1. Buffer overflow flag is brought out in here. So as part of this structure, I could say M arrow buffer overflow. I could check that within my main program prior to unqueuing something. If it turned out there was overflow, I would sort of have to wait until I could put something else in there. That gets considerably more complicated, but it's something you could do.
So what, like a QQ?
Well, no, you don't want to start another queue, but what you'd have to do is do what's called block the queue, so you couldn't put anything more in there. And again, that gets a lot more complicated. Do you wait here? The whole idea of using interrupts is you wouldn't have to wait. Do you somehow tell the stream to stop sending stuff? It gets really hairy, which is one of the reasons it's not implemented here. Okay, any other questions? Okay, again, this will be a 2-week lab, but it is, I hope, I don't say this in a mean way, but I hope in some ways you are feeling a little bit overwhelmed or maybe even a lot overwhelmed. There are a whole bunch of pieces and you've got most of them, but you need to put them together. And my answer is if you're feeling overwhelmed, congratulations, you'll probably make a good engineer. Get used to that feeling. Because the only difference is the problems are going to get bigger and bigger and you're going to make more and more money. Nobody's going to pay you to do something that's already been done. And they can when they can just go buy it off the shelf. They're not going to pay you $100,000 to develop something they can buy for $1,000. So you are going to be doing things that you don't know how to do by and large. And that's part of engineering. So this is a little piece of that. On Monday, I will drop a few more hints, but I'm not going to drop a lot more hints. So but mainly on Monday, I want to talk about the P string and keeping constant strings or any kind of constant data in program memory only, since your RAM is very, very limited. You only have 2K of RAM. Okay, anything else?
Really quickly, I just opened Putty and I tried to get the 328 PB to connect to it. And I
Okay.
checked my devices. I set it to COM6, but for some reason I'm pressing open and it's not opening. I'm not sure if the rest of the stuff are set properly.
Okay, so let me close this. All right, so among the first things you did is you said you went to device manager.
Yeah.
Okay, and let's just go through the steps again. Under ports, it said mdebug virtual COM port, and you had COM6 there?
Yeah.
Okay, that's a good step one. Then you run Putty. And you've got to click on serial here first. My guess is you probably didn't click on serial.
I clicked on the serial option on the side. That's what I did.
You clicked on, oh, okay, you clicked on serial over here. And you changed this to COM6.
Yeah.
All right, so I know you said 6. I'm going to make it 8 because it's mine. 9681. And then you clicked on open.
Yeah,
And
mine isn't opening.
what did you get?
It's not opening anything for me.
Okay, so it just is staying on the screen we had a moment.
Yeah.
Okay, here's what okay, I think this is what happened. I know you said 6, I'm going to do 8. All right, so, okay, and it's just beeping. All right, what you've set up all of the serial parameters. If you click on session, and so you go back to your session, you need to click on the connection type is serial here.
Okay, I see. Yeah, mine was on SSH.
Yep, exactly. So that's what was going on.
Yeah, it's open now.
Okay.
All right. Thank you.
Any other questions?
Where are you going to be uploading this meeting?
I will upload it to M263 exclamation point notes, I think is where I've been putting stuff. Have I uploaded? Shoot, I did everything for 160. Did I do the upload for this course? I thought I did.
I haven't seen any of the recordings.
Okay.
I sent you an email about it yesterday.
All right. Yeah. All right. And you know what? I did the 160 and I may not have done all of the 263, but I will upload it to, this isn't exactly as close, MEC263 exclamation point notes.
Okay.
Yeah, I'll do that right after this. It takes, I don't understand why, but it takes like 20 or 30 minutes for Zoom to do whatever magic it does with the recording and make it available to me. So today's won't be uploaded for half an hour or so, but I'll upload all of the other ones right after we get done with class.
One more thing too. How'd you say you saved this again?
Okay, to save the Putty settings,
Yeah.
okay, you type in this box, whatever the name is, save it. And then it probably makes more sense to name it 9600N81 or something. And then if I open it,
Okay, I see.
okay, and then, okay, the next time I do Putty, I can just click on this.
Hmm.
And,
And then it opens it.
oh, okay, I disconnected this, but all right. But it will open it.
Okay.
Anything else?
No, that should be all. Thank you.
Okie doke.
Thank
I
you.
will, oh, okay, that's open, all right. I'm gonna stop sharing my screen. And I will see you on Friday, folks. Peace.
See you Monday.
I'll see you Monday. That's right, today is Friday. I'll see you on Monday. Take care. Weekend, be safe.
Take care.
You too.